Hello. Are you awake? Are you awake there? Wake up. Come on now. We're not done studying yet. We still have Chem Quest 40 and 41 to do. Let's get right into this. Don't sleep now because we're not done studying yet. Okay, so Chem Quest 40, uh Mr. Lee said that to only do 9 through 11. So we're gonna be doing 9 through 11. Um, yeah. 9 to 11. What is the freezing point of a 2.5 molar molality solution of water, salt water? First, find the freezing point and then subtract the change from the original freezing point, water. Also remember MT is not 2.5 in the two is not 2.5 thing in this problem. So there's a specific formula I'm doing a little bit more plugging and chugging. So hopefully, yeah, shouldn't be too hard to grasp. Here's the formula. First we have yeah, TF here. Oops. We have TF, that's our freezing point. And then we have our KF, which is a factor. It's gonna be constant. We have a table for that. Um, our M is molality, and then our I is our Van 't Hoff factor. Um, Van 't Hoff factor is just like, oh, how many like particles are there? Is it two? Is it one? Type of thing. Cool. Let's go back to it. Um, so first, oh, hold on, let me take a screenshot and then like copy this. Copy and delete. So here's our formula. So first we need to find the KF. The KF is a constant. This will be given on the tests. And so in this case, we have it's for salt water. And so we look at the water on the table. It's 1.86. So TF is 1.86 times our M is molality. In this case, it's given. Then our I. The I is the Van 't Hoff factor. It's just saying like how is it soluble or is it like is it a ionic compound or covalent compound? In this case, salt is an ionic compound. So there's two particles, it's Na and then Cl. Two. You multiply this bad boy out, you're gonna get 9.26. And then it says here to find the freezing point, you have to subtract it from the original freezing point. So 0 minus 9.26. So give us negative 9.3 degrees Celsius. Number 10, find the boiling point of a 3.7 molarity solution of calcium chloride. And so first we need to find the KF. Our KF, so it's boiling point. And so we need to find the boiling point table. First the boiling point. Okay, B. This case, I think we're gonna just assume it's gonna be water because my worksheet it's using the constant for water. So let's just use it. Um, let's use water. It's gonna be yeah. So the constant is gonna be 0.515. The molality is 3.7. And then calcium chloride is how many particles are there? So to determine if it's like the Van 't Hoff factor, you need to find the chemical formula of it. And so the easiest way to tell if it's like if it's if it's covalent or ionic is it so ionic is metal and non-metal. In this case, our problem consists of calcium chloride. It's gonna be CaCl. Ca is a metal right here, and then Cl is a non-metal. In this case, it will be ionic. That means it will be more than one. why is it like this? I'll be right back. Okay, I figured it out. So CaCl, the chemical formula, so calcium is in group 2. That means if a +2 charge, Cl is a -1, is a -1 charge. So right, Ca +2, Cl -1. You crisscross, remember this type of stuff. Haha. CaCl2. So in this case, since it is an ionic compound, how many particles are there? There's 1 Ca, there's 2 Cl. That means it's going to be 3 particles times 3. Multiply this out, it's going to be 5.72. Remember, since it's boiling point, it's going to be, you have to add it to the original boiling point of water. So plus 100, that's 100 is when water boils. So it's going to be 105.72. And number 11, what is the freezing point of a sugar solution with a concentration of 2.5 m? Note, sugar is covalent, so it dissolves but did not dissociate. So, let's find our Kf. Our Kf, our freezing point. Look back here. Oops. It will be I think we're still using water, I guess. So let's use the constant for water, 1.853. And then molality will be 2.25 right here. And then our Van Hoff factor, it says it's covalent, so it'll be 1. Multiply this out, you're gonna get 4.17. But remember, since it's freezing point, you subtract it by 0 in the original freezing point of water. So 0 minus 4.17 will be negative 4.17 Celsius. So notice how like a quick check to know, or like just a quick hack is if it's like freezing point, it's always subtracting it by 0. So if it's positive 4.17, it's gonna be negative 4.17. For the boiling point, you just add it to 100. Yeah, so if it's like 5.72, you just add 100 to it. 105.72. All right, that's Chem Quest 40 for you. Let's move on to 41. So Mr. Lee told us to do skipping 6 through 8. So I think that's just the last page of it. So yeah, let's go into number 1. Number 1 is if 2.75 moles of a certain compound has a mass of 125.9 grams, what is the molar mass of the compound? Any more mass? Yeah. Oh yeah. What the heck? This is easy. Molar mass is grams per mole, right? So 125.9 over moles, which is 2.75. Divide this out, it's gonna be 45.8 grams per mole. Okay, moving on. If you put 2.53 to 24 molecules of an unknown compound on a balance, you'll discover that the mass is 757.8 grams. What is the identity of this unknown compound? Find the molar mass, then calculate the molar masses of the following compound. So let's find out. Okay, so we need to find out what the molar mass of the problem is. So notice how it says 2.53 mol times 10 to 24 molecules, right? We need to convert molecules to moles. And the reason how we do that is we do Avogadro's number, I'm pretty sure. That's like 6.02. So let's just do this. 2.53 times 10 to 24 divided by 6.02. This is the molecule number. Right, it's Avogadro's. Avogadro's. Yeah, 6.02. 6.02 times 10 to 23rd. Divide this out, you're gonna get 4.2 moles. And then you just do grams per moles, 757 grams divided by 4.2 moles. Molar mass is 180. So basically we have to find out all the choices and then find out which one, which like chemical formula it is based off these ones. Like which one is it? Which one is it? This one, this one, or that one. So A C10H12O carbon is 12. 12 times 12 times 10 plus hydrogen is 1.0008 times 12 plus oxygen. Oxygen is 16. This is going to give us 148 and 096. C6 12.11 times 6 plus hydrogen is 1.008 times 12. And then oxygen is 16 times 6. It's 180. C18 carbon times 8 plus 1.008 times 18, 114. And then this last one, 12.011 times 10 plus 1.008 times 12 times 8 plus nitrogen, which is 14, plus oxygen, which is 16, 158. So, as you see here, B is the correct answer. 180 matches with 180. Yeah. Number 3. So this is relating molar mass to colligative properties. When 135 grams of unocovalent compound is dissolved in 450 grams of water, the freezing point of the solution is negative 3.21 degrees Celsius. Find the molar mass of the compound. Follow these steps. What is the molality of the solution? So use MT. Note that since this is a covalent compound, MT equals the molality of solute because covalent compounds don't dissociate. So find the molality. The freezing point is 3.21. So yeah, let's just use the formula for it. It's freezing point Kf, or temperature of the freezing point equals Kf times molality times I. Our freezing point is 3.21 in here. Our Kf is 1.853 because it's water. We're using the thing for water, 1.853. We're using water because it says this right here. Our molality is what we don't know. That's what we're trying to find. The Van Hoff factor is 1 because it's a covalent compound. It does not dissociate. So you divide both sides by 1.853. Molality is going to be 1.73. So how many moles of solute were dissolved? Multiply your answer A by kilograms of solvent. So molality is 1.73. The molality equals moles of solute over kilograms of solvent. So we found out our molality was 1.73. And then we multiply it by the kilograms of solvent, just 450. But since it's grams, you have to put it to kilograms. So it's 1, 2, 3. Move it 3 decimal places to the left to get kilograms. 0.45. This can give you 0.78 moles. And then calculate the molar mass. Molar mass is grams over moles. Our grams is 135. 135 divided by the moles of solute, which is 0.78. Our molar mass is 173.076 grams per mole. All right. 4. Find the molar mass of the covalent compound if 210 grams of substance is dissolved in 810 grams of water. Water changes the boiling point of the solution is to 101.3 degrees Celsius. Okay, so our KF, our boiling point will be this number minus 100, which is 1.3. So right, our KF, our TF, our TB, because it's boiling point, is our KB, our boiling constant, times molality times our Van Hoff factor. Our TB is 1.3. Our KB, since we're using water, we're going to look at the table again. Water is 0.512. Molality is, we do not know what molality is. That's what we're trying to find. And then our Van Hoff factor is 1 because it's a covalent compound. Divide both sides by 0.512. Molality is going to be 2.52. For molality is 2.52. Our moles of solute over kilograms of solvent. In this case, our kilograms of our solvent is 810. So we're gonna write 810. Were you paying attention? Because this was actually a trick to see if you're paying attention. Because we don't actually put 810. We put 0.81. You move it 2 decimal places to the left, you get 0.81. And then we have moles of solute equals 2.04. And then we put grams per moles. In this case, it's going to be 210. 210 divided by 2.04. It's going to be 102.94 grams per mole. Okay, number 5. Last question. Find the molar mass of a covalent compound. If 38.5 grams dissolves in 520 grams of water to give a freezing point of negative 2.15. So our TF, our freezing point, is 2.15. That's positive. Right? And then we just put that 2.15. Our formula is going to be TF equals KF, our freezing point constant, times molality times I. TF is 2.15. KF is water is 0.512. Molality is what we're trying to find, unknown. I is 1 because it's a covalent compound. You isolate the molality, it's going to be 1.16. 1.16 equals moles over 0.52 kilograms. So our moles of solute will be equals 0.6032. You put the grams over that moles. 38.5 divided by 0.603. And that bad boy will be 63.8 grams per mole. Boom! Drop the mic. We're done. Whoop, let's go. That for you guys will be Chem Quest 40 and 41. Hope you guys enjoyed. Good luck studying.